Most people think winter means scarcity, imported food, higher costs, and less control. But right now, the federal government is helping to change that by allowing producers to fully write off greenhouses acquired on or after November 4th, 2025. It's never been a better time to invest in a greenhouse and other food systems that can provide year-round food, even in the harshest climates. So rather than asking how to improve fragile, centralized systems in winter, we ask a different question. What would it look like if food production was designed around winter from the start? That's what we did here at our demonstration farm. Today, I'll show you how greenhouses make fresh produce possible regardless of the season, and how summer harvests are preserved for the cold months. More importantly, I'll be explaining how all of these systems connect to make winter abundance possible. So let's take a look at the greenhouse built for the north, where the outside temperature has no effect on the inside growing conditions. Passive solar greenhouses are buildings that allow us to harvest light and heat energy from nature in mostly passive ways to increase the length of the growing season to 2, 3, or even 4 seasons. We do this by optimizing daytime and nighttime conditions for optimal growing conditions. We also minimize thermal energy inputs by retaining heat with thermal curtains, high efficiency glazing, and ground heat storage. This allows us to grow crops in northern climates that normally would not grow here. Let's have a look at each of these design features that make these greenhouses work. The first thing that you'll notice that's different with a passive solar greenhouse is that the north, east, and west walls are all insulated. On a conventional greenhouse, we would typically have glass or some sort of a poly membrane that allows light through but retains the air inside of the greenhouse. By insulating all of these surfaces, we're able to minimize the thermal loss out of the greenhouse. You'll notice that the glazing surface above me still allows for a lot of light into the greenhouse. This allows the plants to photosynthesize, but it also is what heats the greenhouse up. So by optimizing sun to the south and having insulation on the east, west, and north walls, we're able to get a really great growing environment with minimal energy input into the space. The next thing you'll notice about our passive solar greenhouse is we have a solar wall on the north side of the building. Now this is sheet metal with perforations in it, and you'll notice that the metal itself is black, and so the sun hitting it heats it up. The air gets sucked through these perforations and gets heated up and gets collected by this duct and then injected underground by the fan up there into what we call a climate battery. The climate battery is a series of pipes underground that moves the air below the surface that the tropical plants are growing in, heating it up to about 20 or 25 degrees Celsius. As that air, that warm, moist air, moves underground, it gets dehumidified and reduces in temperature as the energy is transferred to the soil, and then cool, dry air is injected back into the greenhouse on the other side, thus cooling the plants down and removing some of that humidity, which can cause problems if it gets too high. I often get asked what we use to glaze our greenhouse. So our greenhouses typically have a 3 or 5 wall 16 mil polycarbonate sheet, which allows 70% of the light into the greenhouse. This is a really important number because anything less than 70% and our plants are not happy. They need that sunlight to photosynthesize. There's a very interesting thing that happens with polycarbonate in that as the transmissivity goes down, the insulation value of the glazing goes up. And so we end up kind of stuck at that 70% number with an R value of about 2. And it's for this reason that most of the heat in this greenhouse is lost through the glazing surface at night, which is why sometimes we want to put thermal curtains over top of that glazing to increase that R value. Polycarbonate lasts for about 20 years, at which point we would have to replace that polycarbonate in order to keep the production and the performance of the greenhouse high. This may seem like a small detail, but it's really important that we have reflective surfaces on as many of the walls as we possibly can. As the sun hits the white metal on this wall, it reflects back into the greenhouse, giving more light for the plants. And so this is really important. You'll notice on some of our future models that we actually have a combination of white wall on the north as well as a black solar wall on the top in order to try and enhance the amount of light in the passive solar greenhouse. This particular greenhouse actually has a commercial kitchen and a root cellar in it. And so these two pipes are connected to both the commercial kitchen and the root cellar. One of these pipes brings stale air out of the kitchen and injects it into the greenhouse. And so we're able to take any of the CO2 or waste gases from what happens in the commercial space into the greenhouse, which benefits the plants. The second duct has exhaust gases coming out of the root cellar, which keeps the root cellar safe underground and allows us to capture some of that additional low-grade heat in the greenhouse itself. Circulation fans are also really important inside of a greenhouse, and making sure that we've got constant air movement ensures that we have healthier plants. Typically in a greenhouse, one of the biggest issues that we've got with growing plants are plant pathogens. And so these are diseases that attack the plants. And one of the ways that we can keep these pathogens down is by actually creating air movement, which in reality is just mimicking what these plants would experience if they were growing outside. I currently have that fan off just to make recording a little bit easier. Above me, you'll notice that there is a space heater. And so this greenhouse is designed to withstand down to -20 for extended periods of time. But every once in a while, we'll end up with an extreme winter where the temperatures will go well below that. And so in most subtropical and tropical passive solar greenhouses, we want to have a backup source of heat to make sure that we don't ever go below our threshold temperatures and end up killing our plants. Typically, that threshold temperature is going to be dictated by the most sensitive plant in the system. In this case, we're trying to keep our greenhouse above 10 degrees Celsius at all times. And so if we should end up dipping below that 10 degrees Celsius threshold temperature, our heater will turn on and add a little bit of additional heat to make sure that the plants aren't stressed. Let's take a look at some of the plants growing in this greenhouse so you can see what's possible in a northern environment growing in a passive solar greenhouse. Right here we have a key lime. This produces delicious citrus fruit that you can use in a variety of desserts and other confectionery dishes. There's a pink lemon, another citrus that makes dishes so delicious. Here's a kumquat, another citrus. Here's a lime. Here's a Japanese loquat, and there's galangal in the back there, which is a type of ginger. Here's a hibiscus, which makes delicious tea and also is great for pollinators. In the foreground, we have a tea tree, and right behind it, we have an olive. So the principle of a root cellar is pretty simple. We're trying to mimic the temperature that the root crop, potato, carrot, beet, would require in order to stay in a form of stasis for a really long period of time. And it turns out that that temperature is around 4 degrees Celsius and about 85% relative humidity. So in the past, what people would do is build almost like a basement underground and allow the soil of the ground to basically create moisture or humidity inside of the space. And then because this space was put underground, it would take on the temperature of the earth. However, what can happen, as we mentioned earlier, is that if those vegetables start to decompose and there's no fresh air makeup in the space, then all the oxygen can get consumed. And what has happened in the past is that somebody goes in to get potatoes or carrots or beets, and then they collapse. And when they don't show back up for dinner, somebody else comes out to go and see what's going on. They see the collapsed person on the floor, they go in to rescue them, and then they collapse. And so you end up having this cascade of tragedy essentially inside of these root cellars. So to combat that, we put in an earth tube system. And so this device right here feeds into 4 pipes underground. It goes below the frost line about 8 feet down. And those pipes are perforated and they go all the way back up to the greenhouse where we were just standing. So we have a small fan inside the greenhouse that's pulling air through these pipes. And in the winter time, when it's say -20 outside or below freezing, that air will get pulled underground and the ground temperature is fairly stable even through the winter time. And so the air will take on the temperature of the ground. So it'll go from -20 to, let's say, 4 or 7 degrees Celsius, depending upon what's going on underground. And by doing that, by putting that really cold air underground, what ends up happening is the ground ends up freezing. And so we're actually storing ice in a really unique way. We're not having to pull ice out of a lake like our forefathers used to have to do in order to have refrigeration in the summer. We're actually using the cold in the air, pulling it through those tubes and freezing the ground and tempering the air before it comes into the root cellar. This allows us to bring tempered fresh air into the root cellar to make sure that we don't end up with an anoxic environment. Now in the summertime, the opposite is true. So all winter long, we've been pulling air through this system. It's frozen the ground. And so when it gets really warm outside, we don't want that warm air in our root cellar, but we do want fresh air. And so the same system gets used in the same way, except that in reverse. So that warm air gets sucked through this ducting system and the earth cools it down so that it's the right temperature to store vegetables. And then again, we have that fresh air in the root cellar. And so we're able to keep our vegetables fresh longer, allowing us to basically extend the harvest. So instead of just being able to eat when we're harvesting out of the garden, we can actually eat all year long out of this root cellar. So now let's go back into the greenhouse and let's take a look at how the root cellar works, some of the safety features, as well as some strategies that you can use in your home to store some of your root crops throughout the year. So behind me is the root cellar, and above the door, you'll notice that there's a green and red light. And so those lights are there for a really specific reason. When the green light is on, it means that the fan is active and the room is being pressurized. When the red light is on, it means that there's no pressure being detected inside of the room, and thus the fan is likely off and the situation could be dangerous. Now, the reason we have two lights is that in the event that the green light goes off, the chances that the red light is also going to be burned out is pretty low because it almost never gets turned on. And so there's a layer of redundancy there. So let's walk inside the root cellar and take a peek at what's going on in there. We've been actively eating out of this root cellar all winter long, and so there's some crops left, but a lot of them have been consumed. So the first thing to pay attention to is this duct coming in, and the air is coming out quite cool and very humid. This is just a water pipe that we drilled small holes in here. And so there's a fan feeding air that comes from the duct we looked at outside. And it's blowing cold air across the floor, which eventually just works its way up to the ceiling. And so this is humidified, and currently right now it's taking the cold air outside and it's pre-warming it to be the right condition inside of this root cellar. Let's take a look now at the pressure transducer so that I can show you how the lights operate outside, the ones that are green and red for enter or danger. This box right here has a small little pipe going into the duct, and it's measuring air pressure inside of the duct. And so when this box detects that there's air pressure, it means that the fan is not only operational, but it's actually putting air into the room. And from here, there's a little relay that goes to those lights over there, which basically tells which light to turn on or off, which indicates either a safe or a dangerous situation within the root cellar. All right, so the next detail to pay attention to are the bricks on the floor here. So you'll notice that there's a cross pattern in the concrete. That's to create the right resistance to the pressure of the earth kind of coming in against the foundation walls. And so the civil engineers wanted us to have this grade beam to create enough strength in the wall system so that the earth wouldn't push the basement in. But we asked that we have the ability to put these bricks into the place where the cross wasn't, so that we had perforations that would allow humidity from the ground up into the air. And so this looks like it's just part of the floor, but it's actually a really important detail that helps to humidify the space. The next detail to pay attention to is this duct right here. And so this is connected into the passive solar greenhouse. So the air that's coming in through the earth tubes and pressurizing the room has to go somewhere. And so we pick it up on this ceiling duct, which then allows this pressurized air to go into the greenhouse. So if there are any gases in here that we don't want within this space, we have the ability to evacuate them out into the actual greenhouse itself. Root crops are stored in bins like this, and this is a surprisingly resilient way to store crops. We use wood shavings, which seems to mimic the conditions that the potatoes were in when they were on the ground. And these potatoes are in perfect condition in late February. It's kind of amazing. I always get amazed by these simple storage techniques. You can see there's an ear, or you can see there's an eye starting to grow on this potato right here, but overall it's still firm, and it would create an incredible boiled potato if we wanted to go and eat it. So when we're putting them into these containers, we just put a layer of sawdust, then a layer of potatoes, and then a layer of sawdust again. And it's literally just like hamster bedding, but you can also use actual sawdust itself. I'll give you a look of this potato up close. You can see it's pretty much still in perfect condition, ready to be consumed. And just looking at this right now, I'm getting hungry. As the project is still relatively new, we're still getting up to full production. And so this room has a lot of space to be able to grow. We can put a lot more crops in here. We could use this for wine storage, for cheese storage. There's really a lot of different things that you can store down here. It's basically just an earth fridge. Now, before we end the video, we'll go look at where the earth tubes come into the building and a couple of details that are really important over there as well. It's hard to get a sense of the space when you're sitting behind the screen, but just in that direction is where the root cellar was, where we just came out of. Behind this door is where the earth tubes come into the building. Let's go take a look at that. This is where the earth tubes come out of the ground. And so they originate from the duct that we talked about outside. And then they come in and tie into this same duct that goes into the root cellar, which is in the other room. These access hatches here are really important because if we ever need to clean the pipes, we can actually run a fish line and a rope with a rag and some hydrogen peroxide on it to clean the pipes out. Now, up till recently, we haven't had that need. Everything is tight and there's no rodents or anything coming into the pipes that we need to worry about. But it's always good to plan for these things when you're building systems like this so that you do have the ability to maintain them down the road. Down here is where we have the fan. And so this fan is what sucks the air through the earth tubes and then injects it into the root cellar next door. Now you might be wondering what all these racks are for. This room is also underground, and so it stays very cold in here. It just doesn't have the regular air changes that the root cellar does. And so this room is intended to dry age meat or store things that like cold air, but not necessarily have the humidity or the extreme cold that we get in the room next door. And so this is another room for food storage. And I'm gonna show you one more room in the building, which is also another food storage room, but has a completely different set of temperature and humidity conditions, specifically for canned and dried goods. So let's go upstairs and take a look at that next. Okay, this is on the half floor. So right over here is the commercial kitchen. Right underneath us is the root cellar. And behind here, this is our dry storage goods room. So let's go inside and take a peek here. In northern climates, we typically have a pretty short growing season. In this climate here, it can be anywhere from 100 to 150 days a year. And during that period of time, we usually have really long solar days. So the sun stays up for a really long time. It's warm for that period of time. And so we have a very short season to grow a lot of food, which is why food storage is just so important. So canned goods like to remain cool. They don't want the sun beating down on them. And realistically, they want a stable temperature over a long period of time. And so the intention for this room was to be a little bit cooler than the commercial kitchen, stable with no daylight, where we could store flour, pulses, and canned goods. And you can see that we've got a really great assortment of canned goods in here with room for even more. And so we take the food from our gardens and from our greenhouses and we preserve them using pressure canning, using fermentation, using water bath canning, dehydration, and even freeze drying to create a stockpile of food. And in my opinion, the root cellars that we've seen, the dry goods room like this is the original smart fridge. There's no Wi-Fi required. It takes on the stability of the ground, requires very little energy to operate, and it just kind of cruises through the year, allowing us to store huge amounts of food for our family and even immediate families indefinitely into the future. So if you found this interesting and you want to learn more, check out the description in the video below. You can find links to get in touch with us. And make sure you hit like and subscribe and share this video with people that will get a benefit from it. Okay, see you guys in the next video.